Right, welcome to Statistics 1.3. So we're going to be talking about experimental design here and how we can actually set up our various experiments. So to start off, I want to kind of go through the actual steps and phases of us actually running a statistical study or experiment. So first thing that we need to do is identify what we're actually going to be studying, be it people, be it objects, be it whatever, right? So I could say, hey, I'm going to look at Milton High students. I'm going to look at this product which is being manufactured from this factory, whatever it is, right? Then you want to be looking at what variable am I looking for, right? Am I looking for the height? Am I looking for the number of defects that I'm getting? Like what thing am I trying to measure? Is it eye color? Favorite color? Is it number of credits being taken? Whatever it is, right? And then the next thing that we're going to do is, are we going to be doing the entire population or are we going to be doing a sample, right? If you can feasibly do the entire population, that's always going to be the best data you can get. So always do that, right? So if I'm trying to gather data on one particular class, right, I could fairly easily get data from an entire class, right? So I would try and do that. If it's not feasible, so hey, I want data for the entire state of Idaho, right? I can't get data from every single person in the entire state, so I'm going to say no. I'll just do a sample there. Now, most of the time you're going to do samples, and that's fine. That's kind of what this class is mostly about. But once you just decide, hey, I'm going to do a sample, you decide, wait, what type of sampling technique am I going to use? Am I going to do a simple random sample? Am I going to do a cluster sample? Am I going to do a stratified sample? Like, what am I going to do in order to kind of get this, right? And then have a reason for why you were picking that. If you don't really have a good reason to be not picking a simple random, that's typically going to be the best way to kind of go. Then we need our data to add to our data collection plan here. This is the kind of weird part, but you need to try and, before you actually go and gather data, try and address and identify any issues that are ethical, that are dealing with privacy, that might be you infringing on a private business's kind of rights and stuff there. So things that you might want to be watchful for, like you wouldn't go around asking people, hey, how much money do you make? Because like a lot of people find that as a very personal thing, right? So that's a thing that which they might give you a false answer or a wrong answer, or you're just being kind of a jerk because you're asking them these very impolite kinds of questions. So you want to be kind of mindful of those types of things. If you're going into any kind of private business, you really need to get that business's permission before you do any kind of survey or kind of questioning to people that are in that business. In a high school setting, if you're going to be surveying people in the actual school, it's a little bit more lenient there because we have some kind of since we're doing things for educational purposes, we kind of get a little bit more kind of freedom to do things in this particular building. But in the kind of real world, quote unquote, you're going to need to get permission whenever you're kind of in a non-public space to ask questions and things like that. Then you want to go ahead and collect your data, because once you've kind of addressed, hey, here's what I'm going to do, here's some problems, here's how I'm going to get around those problems. Now you can actually go and follow through with your plan and collect your data. Once you have that, we're then going to organize and make determinations about those particular statistics we just gathered. That's a thing which we're going to cover in future chapters, so we're not quite at step 6 yet, so don't worry about that yet. But then the final part here on chapter 7 is a really important part, and this is kind of what all science and statistics is about, is you're not doing one kind of study and then like it's done and you never need to do it again. A lot of times studies need to be run again and again and again in slightly different ways or things like that. So what you need to do is say, hey, here's what I found. Here's some pitfalls that I had, and here's how I would recommend fixing those if I were to do this again. Because if someone wants to do a similar study to yours or to recreate yours, they would look at those kind of notes you made and say, all right, they had problems here, so I'm going to try and address those. So it's kind of your way of kind of helping out the greater community in kind of getting better data and doing things better in the future, because it's very rare that things are going to be done perfectly and right on the very first try. All right, so once we've kind of gone through this process, let's actually kind of go through some more kind of terms, and we'll kind of look at some other things. So first of all, a census. Now, when you hear census, you typically think of the US Census when they actually go around and gather data from the entire population, like as far as how many people live in your household, stuff like that. But the term census really just means you have gathered data from an entire population, right? I gather data from everyone in the population that I'm actually trying to look at, and here's the results that I got. So if I define my population as just Middleton High students, I can get a census relatively easily, depending on what I'm trying to kind of gather data on. Observational study. This versus an experiment are kind of the main two things you're going to be looking at. An observational study is when I'm either just looking at things from the outside and kind of writing and kind of noting what I find, or I'm going to ask people or measure things, which is not going to cause any kind of change, right? So survey-wise, if I were to ask you, hey, what's your favorite color, right? Me asking you that question is not going to change what your favorite color is, right? Or it hopefully shouldn't, right? So that's just me doing an observational study, right? I could also say measure your height, right? Me measuring your height doesn't change your height, okay? So all of those are examples of observational studies. Then we have experiments. Now, an experiment is when I actually provide a quote-unquote treatment to a group, right? Now, a treatment is kind of a misnomer in the English language, because we typically think of a treatment as a thing which makes things better or kind of helps. A treatment is just a thing I am doing which is going to cause change, right? So I could, for instance, say, all right, I'm going to get this group of people, and we're going to dye all of their hair blonde, like bleach it blonde, right? And then we're going to see if they get treated differently or if things happen differently to them over a 2-week period, right? So the treatment was me making them all blonde. Now, me making them blonde isn't to make them better or to help with some kind of problem. It's just to kind of, hey, I'm doing this. I'm going to see, hey, does it cause change when I do this, right? So that's an experiment. I'm doing a thing, and I'm looking at, hey, does that cause changes to happen here? Now, one of the big problems with an experiment is what's called the placebo effect. Now, the placebo effect is a thing which has been studied a ton, and it is repeatedly found that it is a real thing, even though it feels like it really shouldn't be, right? Now, the placebo effect is named after what's called a placebo pill. Now, a placebo pill is basically a sugar pill, which in a lot of medical studies, people are given and told it's real medicine to kind of see if the real medicine helps. So here's kind of how that all works, right? I'll get two groups that are sick from one particular illness, and I will give one of them the actual drug, right? So hey, here's the pill which actually has the real medicine in it to kind of help, and the other one gets a placebo or a sugar pill, which it's just sugar. It's like eating candy, but not as flavorful, right? And they eat it, but they're told that it has the medicine in it, and what they will find is those people oftentimes will actually get better or feel better because they think they're getting medicine. And why that's important is because let's say I'm trying this brand new drug and I just give it to people and they say, hey, I feel better. The drug might not have done anything. It might have done the exact same as a sugar pill, in which case, hey, the placebo effect is why those people feel better, not the actual drug actually working. So That's why we actually kind of have to take into account more things, which I'm going to cover here in a second. But the placebo effect is kind of what we mean by that particular thing. So when I'm designing an experiment, what I want to do is, first of all, find my mouse, there we go. So I'm going to have my population, and then I'm going to do random draws from that, and I'm going to put them into different groups. Now, 2 groups is pretty standard, but 3 is kind of the typical way you want to go for an experiment. So group 1 will probably get the real treatment. So in medical terms, they would get the actual drug. Group 2 would get the placebo or the sugar pill, right? So they get the false treatment. And then group 3 would get no treatment at all, right? So we typically want that because group 2 is purely there to compare to group 1 to say, hey, are they better because of the placebo A effect, or are they better because of the drug actually helping? Whereas group 3 is kind of there to say, hey, are those people just feeling better or getting better on their own versus being helped by the drug? So you typically want 3. There are reasons why you might want 4, 5, 6, but 2 is kind of a minimum when you're trying to do most experiments. You technically don't have to have 2 groups for an experiment, but it's really hard to get good, helpful data if you don't have at least 2, ideally 3 different groups in your experiment. We can also do what's called a block experiment. Now, this is just a slight variation of that exact same thing. So I altered the flow chart very slightly here. And so this is when you're trying to compare one group to another group. So you want to find some unifying factor of this group and that group. So maybe I'm trying to compare, hey, how do underclassmen react versus underclassmen and upperclassmen. I for some reason couldn't think of the word upper. I was just thinking of like bigger classmen, which was wrong. Sorry. Anyway, so we had the upperclassmen versus the underclassmen, right? So I might break those up into blocks 1 and blocks 2, and then I do the exact same thing. I randomize who goes into each of those groups, and then I provide those treatments for it. I think I forgot to mention why we want to randomize who goes into what group. That's really just to kind of reduce unintentional bias, right? If let's say I'm a medical doctor doing this new drug treatment, and in my random sample I get this poor little girl who's really sick, and I really feel bad for her, so I really want to give her the actual drug so that she gets better. I might be unintentionally more inclined to place those people who I kind of feel bad for into the treatment group, and they might have other kind of related things which might cause them to react differently versus it being random. In general, in stats, random is always good. The more random it is, the larger the sample is, always makes things better. So that's kind of why we try and randomize it even at that step there. Okay, once we're done with those treatments, we gather the data and then we compare the results. We're not going to be getting into the comparing of results until later because we're really trying to focus at this current point, how do we gather data correctly? Because if we don't gather data correctly, it's not very useful, and it doesn't matter what the results are. Okay, so the control group, I mentioned this already a bit. A control group is the group which gets that dummy treatment. It doesn't always have to be a physical sugar pill. So let's say you tell them that doing this weird little hand clap thing actually helps them do better on a test. So they do it every single time, whereas some other group, you have them do some other thing which is going to help them on a test, whatever, right? It's any kind of group which is getting a false treatment which actually does nothing but you tell them that it does, right? And we do that to kind of, one, take into account the placebo effect, but also it's a good way to kind of find other lurking or confounding variables that might be causing problems for us. So what I want you guys to do here is to actually pause the video and then try and answer these 4 questions of would it be better to do a sample, an experiment, a simulation, or a census for this particular situation. Once you've kind of answered those, then resume the video and we'll kind of go over the rationale for all of these. Okay, so on these ones here, the first one, we're trying to study the cooling process of a nuclear reactor. Well, if I do an experiment there, I might cause a nuclear meltdown, which is a very, very bad thing to do. So I probably want to do a simulation, right? So have a computer program simulate what would happen if I did X, Y, and Z, and then see what actually happens versus me just going to a nuclear reactor and pushing buttons to see what happens. It's not a safe thing for us to do. Number 2 here, we're trying to get a sample of the amount of time that college students taking a full course load spend exercising each week, right? Well, it's going to be very hard for me to get data on every college kid on an entire campus, just because there's so many people there. So it's probably going to be way easier for me to get a sample, just because a census is going to be way too hard for me to do, right? Number 3, we're trying to study the effect on bone mass of a calcium supplement, right? So, well, this is one where an experiment would work, right? I give one group the calcium, and I give one group a placebo pill, and then I see, hey, does it actually help with their bone mass? And then number 4, I'm trying to study the credit hour load of each student enrolled in your college. And you say, well, that's really hard for me to go and ask every single college kid like in number 2. But the difference is, in number 2, that's a question which I would have to go and do a survey and ask every single person. Step 4, that data is somewhere that someone has in a database which I could just go and ask and they could tell me, right? You could go to the registrar or the counselor and say, hey, how many people are on each credit load? And they could just print it out and tell you or give it to you. And so you could get a census in that way. And that's one of the things that people kind of forget about is if there's data that is out there and already compiled by someone in some place, going there and getting all of that census data is always going to be better than just you trying to go and randomly get it from a number of people. Even a good, well-done, randomly selected group is never as good as the full census is going to be for us. Okay, and then we have some kind of problems with surveys. We've talked about surveys a little bit. I want to kind of go over some pitfalls. There are more than this, but these are just some of the kind of quote-unquote major ones. The first one is non-response. Now, this is probably the most common one, right? You randomize your list, you get 30 people, you try and contact all 30 of those people to take your survey. 3, 4, 5 of them don't take it, and they get it and they just throw it away, whatever. They don't care, right? That's going to affect the outcome because those people didn't respond to it. That's why typically if you want 30 people, you'll ask 40 people because you want that non-response to not affect you as much. But if you get a lot of non-response, then you can get an undercoverage problem, right? I'm only surveying 10 people when I really needed to be surveying 30, stuff like that, right? Truthfulness of the response. People may answer your questions wrong, either because they are embarrassed, they're just trying to troll you and give you false info because they don't like you, or they may not remember, so they think it's this, but they have forgotten it for whatever reason, right? So it's not always malicious. They're not always trying to hurt you or trying to hide things. They may just not remember things, which is kind of similar related to faulty recall, right? So for instance, if I'm trying to do a survey on what did people have for lunch on August 3rd, right? I could go and like ask, hey, what did you have for lunch on August 3rd? And you might say, I don't know, a sandwich, even though you don't remember at all, but just kind of making a guess, right? So your response is wrong, not because you're trying to lie, but because you just don't remember it, or you remember it incorrectly, right? So that's a one that you need to kind of address by making sure that you are asking and trying to get data that people can actually truthfully give, and not have to try and remember things which they don't have any kind of recollection of, right? Then we have hidden bias. This is one that is sometimes harder for some people to kind of see as a actual problem. Now, there's a number of things which could kind of have this happen. You could have things that are worded strangely. It could be worded in a way which is going to be very misleading. Like if you see a lot of adjectives in a survey question, that's typically a bad thing. Because if, like, I say, hey, how do you feel about ultra super violent sports? And people are like, well, those extra words are kind of there to kind of push you in one way. I mean, like super violent and bad, or bad, versus, hey, how do you feel about this particular sport, right? So even though you might not be intending that, that bias can kind of push people one way or the other, and kind of give you some kind of false stuff there. Another thing that kind of happens there with the hidden bias is if you have a super long survey. Like, if you've ever taken a survey which is like multiple pages long, and you're like, by page 2 or 3, you're just like, I don't care. I'm clicking on whatever I can and hitting submit so I can be done with it, right? That's another form of that bias. Now that there's a bias there of people stopped caring after the first page, so the responses on those latter pages is going to be less accurate for you. A way which you can kind of compensate for that is you can randomize the questions so that you have less of it. But ideally, you don't want super long surveys, or you don't get very good data, is what people find. Even though you will still see people giving massive long surveys all the time, and that's bad data. Anywho, next one here, vague wording. Like if I say stuff like, do you often do this, or do you eat fast food often? And people might say, well, to me, often means every day, or some other person might say, hey, often to me means once a week, or some other person might say, well, often means once a month, right? Often and seldom and sometimes, those kind of words, those are things that don't have, that people can interpret in different ways. So you want to be very specific when you kind of ask those like things. Hey, do you eat fast food once a day, once a week, once a month, once a year? Give them those kinds of categories, right? Interviewer influence. So this is a thing which, even though you might think, well, I'm a very nice, approachable person, who would have a problem answering questions from me, right? There's a lot of things which you might not be aware of that people might see and react differently to, right? So I give you some examples here. The tone of your voice when you ask, like maybe you're just in a bad mood because someone was just a jerk to you 5 minutes ago, and you might be like, how do you feel about this? And they'll be kind of put off, and they might give you a false response, just trying to appease you and make you happy. So little things like that. Your body language, if you're more aggressive or more passive, people might respond differently to the question just based off of that. What you're wearing might change that, right? What your gender is. If you're a person of authority, right? If a cop is asking you a question about drinking alcohol, you might respond differently than if it's your best friend, right? Your ethnicity, your age, all these different things could affect how people are going to respond to you. Now, that doesn't mean that you can go and change those partial things about who you are to ask those survey questions, but you need to say, hey, is this the kind of thing which might affect how someone responds to that, right? For instance, me being male is not going to affect me asking, hey, what's your favorite color? But hey, maybe it might, right? Maybe I ask a guy, hey, what's your favorite color? And his favorite color is pink, but he's like, well, I don't want this guy to like know that my favorite color is pink, so I'm going to say blue, right? Simple things like that you might not even think of still could cause that. So easier ways to eliminate that is you add that level of you give them a survey and then you don't watch them take it. You just have them fill it out, or they do it online, and it's also private, so that you won't know who took each one of those. That's a great way to kind of help with most of those kind of interviewer influences there. And then the last one is a very, very common one, and probably one of the ones that I guess that happens the most, but people don't really notice or care. That is voluntary response. A big reason why we do random samples is because that matters a lot, right? If I just do voluntary response, then people are only going to respond if they want to. So a few examples here. Like comment cards in restaurants, like, hey, leave us a comment on how we did, or Yelp reviews, right? No one goes to a restaurant and says, that was fine. I'm going to go on Yelp and leave a 3-star review saying this was fine and I'm pleased. Like, no. People either want to go on there and give it like 5 stars. This is the best thing ever. When I ate it, I felt like I saw the eyes of God when I took a bite of this burger, right? That's a 5-star review. Oh my gosh, like I'm gonna put that on there and yay, right? Or the opposite, right? This is a 1-star thing. It's the worst thing ever. It tasted like I was eating dirt, and it was just, oh, it was horrible. How dare they even approach me with this like food, right? People want to go and put those very strong opinions in surveys, but people don't want to take the time to write a review or a survey if they just have not very strong feelings. And you'll see this a bunch on that kind of thing, but also if you go to a political website. So let's say there's this very conservative site and a very liberal site, and they could both put up the same survey on their sites and saying, hey, how do you feel about this topic, yes or no, right? And it's the same survey, the same question, right? But people might go to one of them, and those two surveys would give you drastically different results just because of who's going there and who's choosing to respond to those surveys. So that's why random sampling and making sure that you ask just those people you have randomly sampled is so important, because if it's a voluntary thing, you're only going to get the people who have a very strong opinion or that are willing to actually respond to your particular question. Okay, I've used these terms a bit in the past, but I want to kind of go over them a little bit more formally here. That is a lurking variable and a confounding variable. They're oftentimes kind of used interchangeably because they are very, very similar, but there are some subtle differences. Those differences I'm going to explain a little bit easier in an example. So a very famous lurking variable is ice cream sales to shark attacks, right? If I do a month-by-month analysis of the number of gallons of ice cream sold per month, and then I match that up to the number of shark attacks per month, you will see that as my ice cream sales increase, my number of shark attacks increase. Therefore, I might conclude that selling more ice cream causes shark attacks, so we should blame Ben and Jerry's for being mass murderers, right? But that's really not what's going on there, right? There is a lurking variable that is causing that correlation to happen. That's typically the weather, right? Ice cream sales go up when it's warm in the summer, and they go down in the winter when it's cold, because no one's like, ooh, it's a nice toasty 10 degrees outside. Let's go get some ice cream, right? But if it's like, hey, it's a 101, maybe I'll stop by Dairy Queen today, right? So you'll kind of see that. And same thing with shark attacks. You get attacked by sharks if you're in the ocean, not always, but that's when it's going to happen, right? And you're typically going to be in the ocean more, and there's more people in the ocean in the hot months in the summer, and less people are in the ocean in the simmer because it's cold, right? So that lurking variable is the variable of the weather or the temperature or the time of year, right? That's the thing which is actually causing the A effect, not the things I'm actually looking at. So that's what a lurking variable. It's kind of think it's lurking. It's like hiding in the shadows and actually causing the change, even though you can't see it. A confounding variable is a variable that either adds to or reduces the A effect which you are already seeing. So a one that I've seen in the past year is people were trying to actually study if they gave more or less water to these plants, would they grow better, right? So they on one half of the room put 30 plants and watered them normally. On the other half of the room, put 30 plants and doubled the amount of water they were getting, right? But the side of the room they were doubling water on was also the side of the room by all the windows, right? So those plants were actually getting more light than the other plants, even though that isn't what they were actually studying. So the extra light was affecting just those plants by the window and causing change as well as the amount of water. So it's really hard in that way to say, well, was it the water which was causing the change, or was it the sunlight which was causing the change? And was it some combination of both of those things? And that's the kind of problem there is that extra variable could be causing change, and you're not sure was it water or light or how much of each was causing the change that we actually noticed. So that's a confounding variable, right? It's affecting one group and kind of either making it worse or better, whatever we're kind of looking at there. Don't worry too much about being able to identify the difference of a lurking to a confounding variable, but just kind of know, hey, here's what those terms mean, and that's the kind of thing we are looking for, and we're trying to help out with these kind of randomized checks. Okay, so in your groups, go ahead and pause this, and then go through these 4 questions here. Not in your groups because you're by yourself. Answer what kind of problems might happen with this particular situation. And then once you're ready, go ahead and resume it here. Okay, so first one here, we have a uniformed police officer who's interviewing a group of 20 college freshmen. He asks each of them their name and if they have used illegal drugs in the last month. You might see why this is a problem, right? This is that kind of interviewer bias, right? He's in a uniform, he's a cop, and he's asking them their name first and if they have used illegal drugs. Most people who have used illegal drugs aren't going to tell a cop their name and that they use illegal drugs to his face, right? So we can kind of see the bias there, right? The second one. So Jessica saw some data that shows that cities with more low-income housing have more homeless people. Does building low-income housing cause homelessness? Well, typically no, right? There's a confounding variable there, or a lurking variable of if there's more homeless people or more poorer people in an area, they will build more low-income housing because of that. Or if a city is larger, they're going to need more low-income housing because they're larger, and just being larger will cause more homeless people, right? So there's a number of things which might be influencing that, right? Number 3, a survey about food in the student cafeteria was conducted by having forms available for customers to pick up at the cash register. A drop box for completed forms was available outside of the cafeteria, right? So this is one, it's voluntary, and then also it's kind of a hassle to actually do this, right? You'd have to pick it up there, take it to your seat, fill it out, and then go to a different place and submit it. So you're going to get that kind of voluntary response, but also it's this kind of not very random, and people are not going to go through the hassle of actually doing it, right? Number 4, extensive studies on coronary problems were conducted using men over age 50 as the subjects, right? So this one's a little bit more kind of not direct, but this is a problem of you take one group and then you try and generalize it about everybody, right? So we said, hey, men over 50, how are their hearts? and then we're going to say, hey, everyone has these problems, well, as opposed to looking at just men in a certain age group, right? If I'm only looking at one certain group, my conclusions that I'm drawing should only apply to that one group, right? So if my study only looks at men over 50, I can only make conclusions about men over 50. And that seems kind of like duh, but you'd be surprised how often that doesn't happen. A famous one was they actually did a study on, does this drug cause an increased risk in cervical cancer, right? That's an important thing to kind of know. But in their actual study, they pulled just men, and they gave just men those drugs, and then looked at the increased rates of cervical cancer. Now you're probably thinking that seems really stupid because men don't have a cervix, and that would be correct. And that is again a major problem of you applying this data to a group which you didn't actually get the data from. It's a much more obvious and kind of stupid case, but it's a little bit easier to kind of see the problem with those kind of more hyperbolic cases and so forth. Okay, so with that, here is our homework for 1.3. So we're going to do 1 and 2, and then we're going to do 3 through E11, the odds. So again, so that you can check your answers in the back of the book. Once you're done with that, this is the end of chapter 1. So there is a review assignment for chapter 1. We're going to do 1 through 11, the odds, and that's kind of just after 1.3. You're going to see that in your book. So with that, I will talk to you guys next time.